Hello, everyone. Welcome back to fifth grade, Unit 4. This is Lesson 6. And today we're going to start talking about decimals with multiplication. First, we started the introduction with decimals and the introduction to money. If you haven't watched those videos, please pause this, go back and watch those introduction videos, and then come back and start this again. And then the last couple of units or lessons, we've been talking about multiplication. We're going to put those together today. So this first part of the video, I'm on page 157, and they are having us think about having a garage sale. So have you ever had a garage sale? We did. We've had a couple of them. Some of them more successful than the others. Some of them we had crazy amounts of people come in to buy things, and some of them not as many. But my boys have also enjoyed trying to sell their old toys, so they have money to, buy new toys. So that's what this first part is talking about. Is some kids are having a garage sale, and they are selling some of their toy cars for 12 cents each. So I've collected some of our toy cars, and I've got a little sign that says cars 12 cents each, and they want us to figure out how much money that's going to be. How much money are the kids going to make? So let's start by saying to ourselves, when we hear that word 12 cents, 12 cents, the cents part, even though it's not a place value number, it kind of is. So it kind of tells us where that place value needs to end when we're writing the numbers. So I'm going to pause this and let's think about that a minute. Okay, I've written the word cent here, and I want you to think of any other words that you know that have that word or part of that word cent in them. And this is not sent like you sent a letter to someone. This is sent like money or numbers. So I'm going to pause the video a second and write down all the words you can think of that have cent in them. Okay, so what did you come up with? Well, this is my list that I came up with, and there are certainly more. So cent, when we think of a cent, we think of a penny as in 1/100th of a dollar, because it takes 100 pennies to make a dollar. And that's a key to what that part of that word means, that word, and then a chunk of lots of other words, what they mean. Century, did you come up with that one? 100 years. What about percent? Per means out of, and cent means 100, out of 100. If we say 100% of something, or 30% off, if we go to a store and there's a sale, 30% off, it means out of 100. What about centipede? Did you think of centipede? Well, they don't really have 100 legs, but they have a lot of legs and they're kind of yucky for some people. So they call them centipede, even though they really don't have 100 legs. But it helps us understand that cent means 100. Oh, one of my cars is escaping there. That can help us when we hear cents. It can help us make an idea about the place value. Okay, so I have 12 cents in my hand. That's the amount that they say each car is going to sell for at their garage sale, 12 cents. To make 12 cents, one way to do it is to have one dime, and two pennies. There's 10, and two pennies is 12. So there's 12 cents. That's one way to do it. You could do it other ways too. So 12 cents. So let's take a look at how just hearing those words, how are we going to know kind of what it looks like or where a decimal point could go? Well, first of all, I just wrote it out in words, 12 cents. That's how I wrote it on the tag too. If you remember, the tag said cars are 12 cents each. But we can also write it with the cent sign. Now remember from our last video, the cent sign comes at the end. So, and it kind of looks like a C, doesn't it? It can help us. It looks like a C, 12 cents. Now, we also sometimes want to write it as a dollar with the dollar sign though. So something's going on here. We've got to figure out where the decimal point is, because if we just left it with the dollar sign and the 12, what actually are we saying the cars cost? We're saying it costs $12. Well, nobody's gonna buy a car at a garage sale for $12 because you can go to the store and get one for like $1, maybe $1.25 or something. So we have to do something. We have to do something with a decimal point to change this from $12 into 12 cents. Well, when we hear the word cents, we know it means 100. That also can tell us about the place value, hundredths. So the hundredths place is also the cents place. So that can help us know, okay, where would we place the hundredths place? And that has to be the last digit in the number because we're reading hundredths. It has to be the end. So that right there has to be the hundredths place. If that's the hundredths place, the cents place, then this has to be the tenths place. And what would be next? A decimal point. And we can't leave that decimal point just hanging out in the middle of nowhere. We always want to put a zero in front of it if there's no dollars, because otherwise people are not sure, is it just a mark on the paper? Are you trying to say decimal? Is it something else that's weird? They don't know. So we need to have $0. So when we write 12 cents, we write, there's the dollar sign. Remember, even though we say dollars at the end, we put it at the beginning. I know that can be confusing for some kids. Now, then we have $0, and actually I'll move that over a little bit so it's a little more orderly, and 12 cents. $0.12. And we hear that word cent at the end of the 12 where the 2 is, and we know that's the hundredths place. That can really help us when we're multiplying as well with decimals. Let's see what that looks like. Okay, you can see I've put out the money that each of these would cost. So if someone came by and said, I want to buy these cars, and here's 12, 12, 12, 12, 12. Whoops, that one isn't 12. Now it is 12, 12. There's 12 cents each. How would we know how much that is? Well, one way, we could just gather up all the money and just count it. That would work really well. But we might want to do it with multiplication instead, because if you start understanding this, it's actually faster than collecting all the money and counting it. So I've written, we've got 6 groups. Times means, I hope you said groups of. So if we're multiplying 6 groups of 12 cents, 6 groups of 12 cents. So if you know your multiplication facts to 12s, you already know the answer to this is 72. And I have found that if you're working on your multiplication facts and you are done with 1 through 9s or 0s through 9s, please go on to 10s, 11s, and 12s. You'll use it all the time. You might not realize it if you don't know them, but guaranteed you'll use it all the time. So 6 times 12, 72. Now, here's the question. Where's the decimal point go? Well, we know it's 6 groups of 12 cents. 6 groups of 12 cents. So we know the answer is going to be in cents, or it might be in dollars, might change to dollars, but it's definitely, if we don't have a decimal place and we're talking about cents, it's going to give us cents to start. So we hear 6 times 12, 6 groups of 12 cents. We know that this, let me give my different marker, we know that the answer is going to end in cents, which is the hundredths place. So if the answer is 72 cents, it ends in the hundredths place because cent means 100. So there it is, there's a hundredths place. So if we know the 2 is in the hundredths place, we're going to put the dollar sign in front. We're going to write the 72 ending in the hundredths place. There's the hundredths place. What place is that? I hope you said the tenths. There's our decimal point. And what are we going to put in the ones place? Well, we have to put a 0. We can't leave nothing. We've got to put a 0. Get rid of the place values. And we know that 72 cents is $0.72. And that's how we're going to write it as the decimal with dollar sign. Remember, we could also write it with the cent sign at the end, 72 cents. All right, here's one that might give you trouble. I hope it doesn't, but it's a little trickier. So in the book, they tell us they're selling 5 puzzles for 30 cents each. So 5 groups of 30 cents. So 5 times 30. 5 times 30, we multiply the 5 and the 3 is 15. Then in all the parts of the problem, there's 1 0. So in all the parts of the problem, we need 1 more 0, 150. Now this is 150 cents because we were multiplying 5 groups of 30 cents. So this is 150 cents. Now, if you know a lot about money, you might already be going, well, if it says 100 something, it's got to be more than $1 because it's 100 something and there's only 100 cents in $1. Could be 100 more than 100, but you can also tell when you look at how many place values, how many places you have in this number. It has to end in cents, so that 0 has to end in the hundredths place because cents means hundred, so it's got to end in the hundredths place. If that ends in the hundredths place, that means this 5 is automatically in the tenths place. There's the decimal point because the decimal point is right in between the tenths and the ones. And this number 1 has to go in the ones place. So we've now turned 150 cents into $1.50. See how that works? When you hear the word cent, you know whatever the last number is, it has to go in the hundredths place. Okay, the next part they want to tell us is how are those kids going to figure out how much money they made? So if they made 27 cents from jump ropes, if they made 8 cents from marbles, if they made 72 cents from cars, and if they made $1.50 from puzzles, they want to know how much money did they get. So they could just take those coins and put them all together and add them up if they wanted to. But we also want to know how to add with decimals, and I hope this is not new for you. If it is, you need to go and watch our Bad Math Dancing video again. I know for sure that we have lots and lots of 5th graders who are going to know exactly how to add decimals because they're going to know we always line it up. Bring it down. If you don't know that song or if you don't know that dance, please, please, please go watch our Bad Math videos because we are awesome dancers. Well, actually, we're not that awesome, but that's why we call it Bad Math Dancing because it's fun. And you don't have to be a great dancer to do it, but it really helps moving your body to remember something. Actually, really, it like gets in your brain better. And I'm not making that up. It's really brain research. So if you don't know how to add decimals already or subtract decimals, go and watch our Bad Math Dancing videos. So here are our numbers. We know if we're adding or subtracting with decimals, we line up the place values and we line up the decimal and we bring it straight down to the bottom. And then we add all of the penny column up, we add all of the dime column up, and then we may or may not have to put in another $1, we'll have to see, but we add all these up. So 8 and 2 is 10, and 7 is 17, so we know that there is 17 cents. We add another dime up here. So we know that 7 and 2 and 3 is 10, and 5 is 15, and those are cents. So we add another $1 up there, and now we're at $2.57. Okay, I've moved on to page 158, and we're going to talk about how does all of this work with decimals and with money? How does that translate to multiplying with decimals? And here is it. It's actually kind of a quick and simple trick, but let's see if we can discover it. So we're going to look at a pattern. What if we had something that we were selling for 65 cents? And I don't know what that might be. Maybe it's a little tiny Lego figure. If you were with me before, we practiced kind of adding up what we should charge for old Legos. And we said people tend to spend more if it's made into something rather than if it's just a group of blocks, Lego blocks sitting around. So if I have this bag of Legos and I want to sell it because these are Legos that I'm done with, well, if I just put them out like this, probably won't get as much money. But if I build them into something quickly, someone's going to come by and go, oh, that's so cool. Look what they build. Can I get it? And they're going to be more likely to buy it. So it's a good marketing strategy. So say we were going to do that. We took those Legos and we built them into 2 structures, and we were going to sell those structures for 65 cents a piece. So 2 groups of 65 cents. What would that be? Well, I hope you said it would be $1.30. 60 cents and 60 cents is $1.20, and another 5 cents and 5 cents is another 10 cents. $1.20 and another 10 cents is $1.30. So I hope you said it'd be $1.30. What if we did 20 groups? It's a lot of Legos, but if you've got a lot of Legos to sell, and plus, you got a little extra time, might as well make them into something, because that way if 20 people come by, well, you can sell 20 of them at 65 cents, which is amazing. So 20 of them 65 cents, how much would that be? Well, that would actually be $13. Now you might say, whoa, how did Ms. Cooperwood add that up so fast? That is fast math. And I will tell you the trick. If you can't figure it out, I'll tell you the trick. And you can see as you go along if you can figure it out. What if sometimes organizations have garage sales? Like maybe our school might have a garage sale to raise money for, some fun activity or a field trip we wanted to go on or something. So what if kids all around the school brought their money, brought their Legos, and made them into little tiny, somethings, cars, people, animals, whatever they may be, and we had 200 to sell? How much money would that be? Now, again, you might be saying, Miss Gubrud, you are fast at math. And the answer is, I am actually fast at math. But why am I so fast at math? Look at the pattern. Think back to the beginning of the lessons, of the units, when we were talking about shifting that decimal place to the left or to the right. If it was 10 times more or 10 times less. If you're shifting the decimal place to the left, it's getting bigger, 10 times bigger. If you're shifting the decimal place to the right, it's getting smaller, 10 times smaller. Now, in this case, we know that it's getting bigger because we're getting more and more groups. Two groups. Here we had 20 groups. Here we had 200 groups. Now, look at how the decimal place is shifting. First, I have 130. Then I move 130 over here, 130, and I have to put in another 0 to account for the cents place. Then I move the 130 over again. Now we need 2 additional decimal places. So see how those 130, my original 130 numbers that I started with, is shifting? Now, there's also something else that you want to know, and this is pretty cool and works really well. Here's the trick. We're going to count up how many numbers are in a decimal place. We say how many decimal places are in the whole of the problem, and we need that number of decimal places in the answer. So in this, 2 groups of 65 cents. We have 1 decimal place. The 6 is a decimal place because it's 6 dimes in the 10th place. We have 2 decimal places. There's 5 cents, 5 pennies. So we have 2 decimal places in the problem. So we need 1, 2 decimal places in the answer. Now, if you didn't know where the decimal place should be on this next one, if you take 20 times just 65, not 65 cents, just 65, 20 times 65 is 1,300. So if you grabbed your calculator and said, hold on, Ms. Cooper, I'm going to do that quickly, 20 groups of 65, I grabbed my calculator, it gave me $1,300. So if you made 20 groups of your Legos and charged to 65 cents, then it would be 1,300. I hope you didn't do that, or I hope you said, oh, I think something's wrong. You're not going to make $1,000 at a garage sale selling 20 Legos. That just doesn't make sense. Instead, you have to know there's 1, 2 decimal places in the whole of the problem. So we need to take this 1,300 and we need to make two decimal places, and those decimal places always have to go on the right because that's how our number system works. So those two decimal places, and then how do you show that those are decimal places? You have to add in a decimal. There it is. Well, $13 makes a lot more sense. Let's look at this one. If you took your calculator and typed in 200 times 65, you would get 13,000. Now, I would love to make $13,000 at a garage sale. I can tell you what, I would be having one today. But you're not actually going to make 13,000, even if every 200, all 200 students brought in a little piece of Lego for 65 cents. We're still not going to make $13,000. So we have to say this isn't $65. When we type it into the calculator, when we type this in, we type it in as 2, 0, 0. Then we type the multiplication sign. Now, how do you type in 65 cents? Well, you type in 0 and then the decimal point. You have to type in the decimal point. Then the 6 and then the 5 and then the equals. So that's how you type that into the calculator. 200, multiplication sign, 0, decimal point, 65 equals. Well, now let's take a look. In this whole problem, there's 1, 2 decimal places in the problem. So we need 1, 2 decimal places in the answer. It always starts at the right-hand side because that's where the cents go. That's where we read numbers left to right. So when we get to the very end, it has to be the decimals. We put in the decimal point and we find out it was $130.00. Okay, last part of this video. On page 159, it wants us to practice multiplying with decimals using that same strategy of choosing any method to multiply. And again, please do practice the any method to multiply. Don't just grab your calculator and quickly type in 2/10 times 421 and get the answer. Please don't do that. That won't help you. Instead, use your calculator to check yourself. See if you got it right. So if you multiply 2 times 421. Just pretend it's not a decimal. The first step is take the decimal place out. Pretend that there's no decimal place at all and multiply 421 times 2. You can use any method at all. You will get 842. When you get 842, you have to go back and say, wait a minute, this was a decimal problem, so I have to make sure that there's a decimal in the answer. So we're going to look in the whole of the problem. You're going to look for how many numbers are in a decimal place, in a decimal place value. In this one, we only have 1, and it's this 2. That 2 is in the 10th place. It's the only number in a decimal place. This is a whole number, whole number, whole number. So since we have 1 place value, decimal place, in the problem, we need to have that in the answer. The question is, though, which of these numbers, or maybe a different number, is supposed to be in the decimal place? Well, remember, we read left to right, so the decimals always come at the end. So that 2 has to be a decimal place. What that means is in order to make it a decimal place, we need to put the decimal point right in between the 4 and the 2. So it's now 84 and 2/10. Let's do that number 20. So that was number 16 on page 159. Here's number 20. 2 and 1500ths times 35. Now again, if you take out the decimal place, and if you multiply 215 times 35 using any method except your calculator, don't use your calculator right now, but if you multiply 215 times 35, you will get 7,525. You'll get 7,525. But then you need to remind yourself you're going to go back and put that decimal place right back in where it was, because this is a decimal problem. So you have to figure out how many digits were in a place value that's a decimal place value. The answer is the 1 is in the 10th place. Is that it? I hope you said no. The 15 is also in a decimal place value place. That's in the 100ths place. What about in the 35? Nope, those are both whole numbers. This is in the tens, that's in the ones. What about the 2? Also in the ones place. So in this whole problem, we have 2 numbers that are in decimal places. So we have 2 decimal places. That means that in our answer, we're going to say equals 2. We also need to have 2 decimal places in the answer. We read left to right. The decimal place is always at the end. It's always at the right-hand side. So these last 2 decimal places are where we need to put in our last 2 decimal places. We know those are decimals. These then are whole numbers. How do we show that? We put the decimal point in between the decimal places and the whole number. So our answer is 75 and 25 hundredths. I hope this video was helpful. Good luck on lesson 6, and I'll see you next time.